All right, a little extra review before the quiz. So name a tangent. Remember, a tangent goes and just outside the circle and just touches the circle in one spot. So on this one, here's the point of tangency that this line just barely touches. All right, so that would be GE or EG, however you want to name it. Technically, it should be arrows because it is a line. All right. All right. PQ, if PQ is 130, so this is 130. Well, first off, how many degrees are in a circle? 360. If we take away 130, that leaves 230. Now, the trick of this one is we're trying to find RQ, which is down here. Okay. Now, there's 230 left, but notice how these are both 7. That means this arc and this arc are equal. So if we divide this by 2, we get 115 degrees for each of them. Identify the given arc as major, minor, or semicircle, then find the measure. Well, right off the bat, we have 2 letters, so we know it's going to be a minor arc. Now, there are a few different ways to do this. Notice how we have every pi piece, 60, 120, 60, and 65, except for Q. All right? So we can add those up and subtract from 360, and we'll find NQM, or arc NM. Another way is to think about it. We have a semicircle here, which is 180 degrees. So if we add up 60 and 65 and subtract from 180, we'll still get the same measure. It doesn't matter. That's probably a little quicker because you're adding up fewer numbers, but you're using the calculator. You're probably saving 10 seconds. But that would end up being 55 degrees. All right, point B is a point of tangency. If it's a point of tangency, that means it's a right angle, which means we have a squared plus b squared equals c squared again. So always identify your hypotenuse. Well, this one's a tricky one. My hypotenuse is r plus 9. And then here's my a and here's my b, or whatever you want to call it. So I have 15 squared plus b squared equals r plus 9 squared. So this is 225. I guess I should have left this r. So when I square this first, r squared. I multiply and double, so 9 times 2 is 18, r, and then I square the 9. Well, the nice thing is the r squareds cancel each other out. All right. If I subtract 81 from 225, I get 144. And then if I divide by 18, I get 8. All right, find the value of x. In this case, these two segments are equal to each other. So I'm going to subtract 7x, move my letters to the right, keep it positive, which means I'm going to move my numbers left. So this gives me 8. That's 2x. When I divide by 2, I get an answer of x is 4. Remember, if you need to hit pause anytime, feel free. Okay. So we have a point in space, and we have 2 tangent lines. hitting the circle. Well, that means they're equal to each other. So we just do the same thing. 2x plus 1. This time I'm going to go left with my letters to keep it positive, which means I'm going to go right with my numbers, which gives me x equals 5. Find the radius of C. All right. Well, once again, these lines are meeting these two chords, right angles. Whoops. These are equal to each other. So we're going to do the exact same thing. I'm going to keep my letters on the left, positive, which means I'm going to move my numbers right. That gives me 4x equals 16. Divide by 4. Sorry, I jumped the gun because I forgot, even though I read it. We're finding the radius. All right. I need to find 4. I do need to find this number. Okay. So when I plug that in, I get 18 for UC and ST. I'm sorry, CV. So if you think about it, that's this. All right. So I'm trying to find the radius, CS. CV is 18. Now it tells me ST is 12, right? Which means this is 6 and this is 6 because it bisects it. So what we have here is a right triangle, and we have this being 6 and this being 18, and we're trying to find the hypotenuse. So we need to do 6, love that, 6 squared plus 18 squared equals c squared, the hypotenuse squared, whatever you want to call it. Okay? So 6 squared is 36. 18 squared is 324. We add 36 to 324. We get 360. And we're going to take the square root of both of those. Well, that breaks down. The magic number that goes into this is 36 times 10. And that's where we get the 6 root 10 for the radius. But we do need to find x first, and then do Pythagoras to find the hypotenuse. Name the circle. Well, that's simple. That's circle A. We put a circle with a dot in the middle, and just put the letter of the center. JLM. Now that being 3 letters, right off the bat, without even looking at it, means that this is either a semicircle or a major arc. So let's see what we have. JLM. So if we can't go left because that would be JML, which would be a semicircle. So we're going JLM, which means we need to add up 120 plus 60 plus 65, which is 245. Now again, if it was JML, which means something totally different, right? That would go this way, and that would have been a semicircle and 180 degrees. So the order you go matters. All right, determine whether AB is the diameter of each circle. Explain your reasoning. Okay? So AB bisects MN and 90 degrees, so it's a perpendicular bisector. So there is the explanation. Yes, because the chord is being bisected at a 90-degree angle, and it's by the perpendicular chord bisector converse, it is the diameter. So since it is bisecting it at 90 degrees, yes, it is. All right, point of tangency, B. Find the radius, R. Okay, so this is one of those ones again where we're doing a squared plus b squared equals c squared. Why will it not let me write? All right, so here's my right angle. So R is one of my legs. 21 is my other leg. And then again, this is R plus 9. Okay, so on the left side, I get R squared plus 441. On the right side, I get R squared, multiply and double, square that. Now when I subtract R squared, cancels out. And then when I subtract 81 from both sides, I get 360 equals 18R. If I divide by 18, I get 20. Name a secant. Remember, a secant goes through both parts of the circle. So some of you might think, what about ED? Well, it's not going through the circle, technically, but it is hitting here. I don't know why. There we go. All right. So this would qualify as a secant. So either one of those. So GC, CG, BE, or EB. Tell whether the given arcs are congruent. EF, which is here, so it's 75, and GH, which is 75. So, yes. Because they are in congruent circles with congruent central angles. Because you know they're the same size circle because the diameter here is 8, which means 4 and 4, and that's what we have over here for radii. So the circles are the same size. All right, identify major, minor, or semicircle and find the measure. Well, NLK has to be a semicircle or a major. So N, L, K, semicircle, 180. Tell whether it's tangent or not. Well, if it's tangent, it doesn't look like it because this needs to be a right angle. But looks can be deceiving, so we're going to do 5 squared plus 11 squared. See if it's equal to 13 squared. So what we have here is 25 plus 121 equals 169. When we add these together, we get 146, 169. So no, not a right angle. Name 2 chords. Remember, a chord is from one endpoint on the circle to another endpoint. So we have HC or CH or BD and DB. Again, even though BD continues outside the circle, a chord is a segment of a secant. All right. QR equals ST, and they're both 12. Okay. We're trying to find CU. So this is the easier one. We're just trying to find this. Okay. So therefore, we actually don't even need this information because all we're doing is finding X and plugging it in, which we've already done. So this gives me 4x equals 16, and therefore X is 4. And when we plug it in, 7 times 4 is 28, minus 10 is 18, or 4 times 3 is 12, plus 6 is 18. Now remember, you got to pay attention to what it's asking for, like I didn't do before. It's asking for CU, so all we had to do was find x and plug it in. If it was asking for the radius, that's when we'd have to plug in our numbers and do Pythagoras. Tell whether the given arcs are congruent. STV and UVT. So the answer is no. Arc STV has a central angle of 120. All right, so think about it. We have 30, we have 180, we have 90, and 90 plus 30 is 120, which makes this 60. So STV is 90 plus 30. UVT is 90 plus 60, 150. Name 2 radii. So remember, radius goes from the center out. So in this case, we have AB or BA and AD or DA. LMN, once again, must be a semicircle or a major arc. So from L, we go to M. All right, so this one just goes there. So this one's kind of deceptive. It really should just be LN. There's no need for that third letter. All right, and then think about it. If this is 180 diameter, then we have 60 and 65. We add those together and subtract to get Q, right? And then we just add that number and 65 together to get 120. All right, point out here, hitting the same circle, tangent. So what we have is 2x squared plus 2x equals 7x plus 12. Now in this one, we need to get everything to the same side, and we're going to do some factoring. So 2x squared, 7x minus 7, 2x minus 7x is negative 5x. And then we're going to move the 12 over. And now we need to factor. So 2x times 1x. And then we need to make 12. So 1 and 12, 2 and 6, 3 and 4. Okay. So I'm just going to start with 3 and 4. And this gives me 3, and that gives me 8. I guessed right. 8 minus 5 is 3. 3 minus 5 is negative 8. Since I want negative 5, I want the bigger number, 8, to be negative and that to be positive. So I set each of these equal to 0. This gives me negative 3 halves, and this gives me positive 4. And those are my two values for x, negative 3 halves and 4. That's it.